Hey, good day to you all. In this short video, I just wanted to, give an answer to one of my subscribers about how to calculate fire correction. In this short video, I just wanted to give you the principles of doing that, not really a precise or whatever calculation, because it would take quite some time. I just want to make you understand how these things are done, the principle, because every army and every system requires something else. If you understand the basics, you probably can adopt to any of those systems. Anyway, in order to do that, I just set up, you have a little scenario here. I have the gun here and I have a target here, and in order to shoot that, well, obviously what I need is the distance and the azimuth to that. I put my map tool on that, I rotate onto the target, and I just understand that it is 4,000 meters. The distance and the azimuth is what? 3260. So I have a 4,000 meters distance, and I have a 3260 meters azimuth. Well, let's suppose I'm calculating everything and I make a shot, and I want to correct that shot. In order to do that, for the correction, what I need is any kind of plotting tool. You see that with this map tool, I have with my 6000 map tool, you have this plotting tool. This is it's a very basic version of a fire correction plotter, but let me just explain how to use it. Anyway, you have with the ACE, you have the built-in plotter, which is pretty fine, but probably it is a way too accurate for our purpose. So just let me explain how to use this, and you probably can understand the rest. Anyway, so what I have here is what I need first is to know two data I need basically for correcting any artillery fire. You see, I have my target here, and wherever my impact falls, I need to understand that 1 mil of azimuth change and 1 mil of elevation change, in what distance it will result in that particular range. So if I change the azimuth, what distance my impact point will move left to right or right to left, whatever I change the azimuth. Or if I change the elevation by 1 mil, what distance it will result in at that particular distance. You see, if I'm changing my elevation, probably I'm shooting high angle here. If I elevate my gun 1 mil, it will go a little shorter. But shorter, I need to know. If I change 1 mil, let's say clockwise, you see, my impact point will move clockwise. But how much? Probably the azimuth change is easier one to calculate, because the beauty of the mil system is that at any given radius, well, whatever the radius is, at that particular circumference of any circle, if you change your perspective by 1 mil, at the radius you move 1,000. At the circumference, you move 1,000 of the radius. So what I mean here is, if I'm shooting at 4,000 meter, if I change my gun azimuth 1 mil back and forth, it will result in 4 meter change back and forth. You see, it's pretty easy. If I change from my shooting perspective, it's 4,000 meter. I change my azimuth plus 1 mil, I will shoot somewhere here. You see, plus 2 mil somewhere here. And how much? Well, exactly 4 meters. 4, 4, 4, 4. If I change 1 mil minus, it's counterclockwise, so minus 1 mil, I will say like 4 meters. So if I change 10 mils, I will shoot. If I change minus 10 mils, I decrease my azimuth with 10 mils. What I will do here is I will shoot on its right 40 meters. So it's pretty easy. It's not really difficult. The difficult part is to calculate the distance. Well, the elevation change. In order to do that, you need the range table. I have so really hard times to bring up these range tables. I have no idea. If someone can give me a solution for this problem, I would really appreciate that. Anyway, so you have your range table, and you see that I want to shoot high angle at 4,000 meters. Charge 4 will not get there. Charge 3, high angle. You see it gets there. 4,000 meters. That would be here. 4,000 meters. The elevation is 1071 to 1071 meters. How do I calculate that 1 mil of elevation change, what range change it will result in that particular distance? Well, it's easy. You see, in order to achieve 50-meter range change here, to let's say from 4,000 to 4,050, you need to change your elevation. What? 71 to 63. That you need to at high angle. You need to decrease your elevation with. Let me calculate that with 1071 minus 1063, so that means 8 mils. So in order to achieve 50-meter range change, you need 8 mils. So what you need to do now is you divide 50 by 8 and you get that it's 6.25 meters. So at that particular distance, 1 mil of elevation change will result in 6.25 meters of range change. You see? So the azimuth change is how much? 4 meters? Any azimuth change will result in 4 meters of horizontal impact point change, and any elevation change will result in 6.25 meters. You will understand why I'm calculating this, because let's say I have this yeah, well, I just shoot, and let's say it falls here. So this is my impact point. You see, IP impact point, and well, the forward observer is a profession of its own. He has all the tools and all the knowledge to relay this data back to me. Let's say he's using polar things, which means that he will report me back. So you see, he will relay me back the information that the impact point is 180 meters to the west, and what is it, 75 meters to the south. Why is it important? Because I know that my azimuth was what 3260. So I rotate my thing into the 3260, and you see that I just realized that from my perspective I need to change horizontally 150 meters minus 150 meters, horizontally minus 150 meters. I need to change here minus 150 meters. And range-wise, from my perspective, in order, with moving 150 meters to the counterclockwise minus, I will get to this point, but also I need to shorten my range by how much? You see, it's exactly 100 meters. So I need to decrease my range with 100 meters. Here I go. Here I need to do minus 100 meters. Minus 100 meters. And all I need to do is do the math. You see? 1 mil of azimuth change will result in 4 meters. So in order to achieve 150 meters, what I need to do is I have 150 meters. I divide it by 4. That means 37.5 mils. So my correction is minus 37.5 mils. That is my horizontal correction with this shot. As far as the range goes, well, you see, I need to shorten 100 meters. So 1 mil gives me 6.25 meters. So 100 meters divided by 6.25, that is 16 mils. So in order to shorten my range, I'm shooting high angles, so I need to elevate my gun. So what I need to do is to add 16 mils. Add 16 mils to my elevation. You see, that's how you basically plot out and calculate your corrections. And you do it as much as you can. Well, a question often comes, how accurate you need to be. Well, you don't need to be more accurate than your gun is. Well, a D30 caliber, caliber gun at that particular distance should be what, 25-30 meters circular probability error. So you don't want to go down to centimeter or meter accuracy. It's 10 to 15 meters of accuracy is pretty enough. So that's how you calculate your correction and your solution. Yeah, you've calculated your solution. That's how you calculate your correction. I hope you enjoyed it. If you have any further question, please just ask.